So far in your basic statistics class, you have learned about how to summarize and graph one variable, one categorical variable by itself. Then we follow that up with how to summarize and graph two categorical variables together, just to see if we can spot a dependence between the two categorical variables or not. So it's a good time to look back. So on this page, we'll be looking back at what we've covered so far. We started by talking about categorical variables, and we went first the route of considering just one categorical variable by itself on which data has been collected. We saw that we can summarize this categorical variable by using either a frequency or relative frequency distribution table. And then we also learned that we can also graph or visualize the information contained in the data collected on a single categorical variable by using either a pie or bar or Pareto bar chart, or Pareto chart rather. Then, for categorical variables again, we considered the instances of two categorical variables. And for two categorical variables, we can summarize both together by using a joint frequency distribution table, which is a fitting name since we're talking about two variables, or this table is also called a contingency table. And for two categorical variables, we can graph or visualize using a side-by-side or a stacked bar chart. A stacked bar chart is also called a segmented bar chart. So this is what we have covered so far as it pertains to categorical variables. So we want to move on to the next important detail. And that next important detail is to remind us that whenever we collect data, usually the constituents of data are either categorical or qualitative variables. So here on your screen, as far as collecting that data is concerned, you're likely to have categorical variables and sometimes as well as numerical or quantitative variables. So at this point, we're going to throw a spotlight on numerical or quantitative variables. We proceed to page 15, and that takes us to organizing or presenting quantitative or numerical data. So the first question we'd like to answer is, how do I summarize one numerical or quantitative numeric variable? You can use either an ungrouped frequency distribution table, or you can use what is also called a grouped frequency distribution table. Naturally, the question we would like to answer is, when do I use a grouped frequency distribution table, and when should I use an ungrouped one? To answer the question pertaining to when you use grouped versus ungrouped frequency tables, we are going to use examples to illustrate them. In particular, you might quickly note that depending on the range of values, that is from the lowest value to the highest value, covered by a variable, by a quantitative variable rather, by a numerical or quantitative variable, we can summarize the variable using a grouped or ungrouped frequency table. Remember, frequency represents the count or the number of times a value of that data variable occurs. So here's an example that will show when to use an ungrouped frequency distribution table. In this example, we're given the data below, and we're required to develop a frequency distribution. Take note, we're not told whether to use ungrouped or grouped. We're going to see how we can make the correct judgment on which frequency distribution table to use. The first thing I will do is to look at the range of values in this data set. And what you might observe is that the least value here is 0, whereas the greatest value is 10. They are all individual discrete or count values. That is, there are no decimals. So this ranges from 0 to 10, and they are all discrete whole number values. Whole number values. So this means that I have a number whose range is not too large. So the next question I'll ask myself is, do I need an ungrouped or grouped frequency distribution? To explain my choice, one thing I will do is this. I will observe that if I can write 0 to 10, the different or distinct numbers in this data set, if I were to list them, how long does that look? If it's not too long, well, an ungrouped frequency distribution table will be useful. To emphasize, an ungrouped frequency distribution table, would be fitting. By ungrouped, we mean each of the number is in its own group, is by itself. It is not grouped with any other number. In a little bit, we're going to learn about grouped, and then you'll be able to draw the contrast. So again, since the range of values is from 0 to 10, which is not a very large range, and I can see that if I list the numbers individually, this does not constitute an exceedingly long table. I can tell that it is okay not to group each number with any other number. The next thing will be to write the respective frequencies for each possible data value. So, how many zeros do I have in this data? I have 1. And then how many 2's do I have in this data? I have 1. How many 3's do I have in this data? I will count. I have 3. And I'm going to complete the table. So now I have written out the counts of the different frequencies. The next thing I might possibly want to do to help myself before I proceed to relative frequency is to write the total frequency. Add up all of these numbers, you will get 30. Make sure that this count agrees with the count of all of these numbers. This is important because it helps you to check if you double counted or if you missed a number. And now we proceed to relative frequency. To get your relative frequencies, for the first frequency we have 1. The corresponding relative frequency to that will be 1 out of 30, which will give about 0.333. And so, if you multiply that by 100, this is 3.33%. And then, again, another 1 out of 30, that will be 3.33%. And again, for the next one, it is 3 out of 30. 3 out of 30, that is about 10%. Then 4 out of 30. So right here on the screen, I have provided all of the other relative frequencies. It is important to note that, again, when you add up all of these frequencies, the relative frequencies, it must be 100%, which means 100 divided by 100, which is equal to 1. Remember, this is important to note. Also note that each of the relative frequencies, like 3.33%, actually represents a ratio or a decimal, which is 3.33 divided by 100, and that is 0.0333. So this can also be an alternative representation of your relative frequency using just decimals. Then, we now proceed to the new idea of cumulative relative frequencies. For cumulative relative frequency of the first, they always match with each other. That is, the relative frequency and the cumulative relative frequency for the first data entry in the frequency distribution table always match. Then we proceed with 3.33% added to this guy approximately will be 3.33 plus 3.33%, that is about 6.66%. Then 6.66% plus 10%. So as you can see, we're going zigzag. 3.33% plus 3.33% gives 6.66%. 6.66% plus 10%, that will give 16.66%. Then 16.66% plus 13.33%, that will give approximately 30%, and this continues. I'm going to complete that. So on your screen, you will observe that we have successfully added up all the cumulative relative frequencies. So to get the first cumulative relative frequency, it is always the same as the first relative frequency. The second relative frequency, the second cumulative relative frequency is the addition of the first and second relative frequencies. The third cumulative relative frequency is the addition of the first three relative frequencies together. So also observe that the last cumulative relative frequency, 100%, is always equal to the total relative frequency. These points are well worthy of notes. So we proceed to another example. 20 students were asked how many hours they worked per day. Their responses in hours are as follows. We have all the different data values. We are to determine the frequency, relative frequency, and cumulative relative frequency for this data. I encourage you to pause the video at this point and try to complete this. And also try to convince yourself why we're using an ungrouped frequency distribution table where each data value is recorded by itself. Assuming you paused the video, it is time. Let us see how to complete the frequencies, the relative frequencies, and the cumulative relative frequencies. So for 2, I'm going to count how many 2s I have in the data set. So I have 1, I have 2, and I have 3. So I'm going to record 3. And I can do the same for 3 up to 7. If you have done it, you should have 5, 3, 6, 2, 1. And the total frequency should be 20, which should match the total number of data values here. Then for relative frequency, the first relative frequency will be 3 out of 20, which represents 0.15 or 15%. The next one is 5 out of 20, which represents 0.25 or 25% of the data set. And then we have 3 out of 20, which is another 0.15, which is 15%. I'm going to complete the rest. So on your screen, we have completed the remaining relative frequencies. And then we move on to cumulative relative frequency. In this case, the first cumulative relative frequency is 0.15, same as 15%. The second cumulative relative frequency is the addition of the first 2 relative frequencies. And that will be 0.15 plus 0.25, that will give 0.40, which is same as 40%. The third cumulative relative frequency will be the addition of the first 3 relative frequencies, and that will be 0.40, which is the addition, or the sum rather, of the first 2 relative frequencies plus the third one. So 0.40 plus 0.15, and that will give 0.55, same as 55%. The fourth cumulative relative frequency will be the total of the first 3 plus the fourth relative frequency, and so that will be 0.55 plus 0.30, 0.85, 85%, then 85% or 0.85 plus 0.10, 0.95, that's 95%, and 0.95 plus 0.05, that is 1, or 100%. Again, note, the final cumulative relative frequency is always equal to the total relative frequency. Now note that because of rounding off errors, the relative frequency column may not always add up to 100% exactly, or 1. So, and the last entry in the cumulative relative frequency may not exactly be 1. It might be 0.9999999 forever, or 1.000000001, but they should, however, be very close to 1. With that completed, we proceed to the next page, where we begin to learn about when grouped frequency distributions are used. To quickly illustrate, look at the different classes here, or groups here. In this case, how many classes or groups do I have? I have 1, 2, 3, 4, 5, 6. So in this case, there are 6 classes. We call it classes in statistics. You will call it groups. In the first group, it ranges from the numbers -60 to -40. In the last group, we have a group of numbers here from 40 to less than 60. So, what does this data represent? For context, let's read the preamble. The following cumulative relative frequency distribution summarizes data obtained in a survey or study of the ending overages in dollars for the cash register balance at a business. So at this business, there was a consideration that there are sometimes shortages in the cash register balance, and sometimes there are overages in the cash register balance. Negative values represent shortages, whereas positive values represent overages. That is when you have more than you actually sold. Some people left their change and what have you. So let's begin. Looking at this table, we can answer some questions immediately. For example, we are to determine the proportion of the days in which there were no shortages. To answer that question, we are looking at days where you have positive values or positive cash register balances here. And that will cover this group, and this group, where there were no shortages. And since we're interested in proportion, that would be a match for relative frequency. So that would be the combined proportion or relative frequencies here. So this would be equal to 0.32, 0.40, 0.04. And this is equal to 0.76, which is 76%. Question B. Determine the proportion of the days the cash register was less than $20 off. Less than $20 off could mean off in the negative, which is a shortage. And to see those, let's take it one after the other. For the shortages, where it was less than $20 off, that will be right here. And for the overages, that is where it was in the positive, we can see that right here. So for the proportion, that will be the combined total of these two numbers. And that will be 0.16 plus 0.32. This is equal to 0.48 or 48%. Then question C. We are to determine the proportion of the days the cash register was less than $40 over and at most $20 short. Okay, so let's start with the purple group. I'm going to erase this, and I would like to count cases where it was less than $40 over. So that will be right here and right here. This is less than $40 over, because less than $20 over is also less than $40 over. Then where it is at most $20 short, that's in the negative span, this is this value. So in other words, we need the combined total of these three numbers, which is equal to 0.16, 0.32, and 0.40. This will give 0.88, same as 88%. So at this point, we have completed a quick question on a grouped frequency distribution. It also has cumulative relative frequency, so we can call it a relative, cumulative, or cumulative relative frequency distribution. We'll now proceed to the next page. In this example, we're told that a shipping company recently selected a random sample of 36 airplane weight slips for crates shipped from an automobile parts supplier. The weights, measured in pounds, for the sampled crates are shown below. Here are the data values. Step 1, we have to create a data array for the weights. That is, we would like to sort them from the least to the greatest. What you immediately see is from 78 to 99. You know one thing I would not like to do? I would not like to use an ungrouped frequency distribution here. That is, I will need to write for the classes 78, 79, up until 99 individually. This will lead to an ungrouped frequency distribution table, which is not at all a summary. So this means I have a necessity for a grouped frequency distribution table. So what am I going to do? First of all, I will need to determine how many classes or groups I would like to group each of all of these numbers into. Well, I have set up with, I would like to divide them into 5 groups. So if I choose, for example, to start with 78, so I'm going to have 78, and the next thing is, how far should I go? In other words, you want to determine what is called the class width. In order to determine the class width, you might observe that that is part of the question here. So I'm going to segment this and say my class width, the class width that I would like to use will be, what is the biggest number here? The biggest number is 99 minus, what is the smallest number? 78, divided by how many classes have I said I would like to divide this into? 5. So this would give approximately 4.2. Here you round up. Regardless of the size of this number, I'm going to round up to 5. So that means if my class width is going to be 5, the very first class should have 5 possible numbers. So if I'm starting at 78, for example, 78, 79, 80, 81, 82. So this goes from 78 to 82. So I'm going to write that as a class in the following way, 78-82. Then the next one will start with 83, 2, 83, 84, 85, 86, 87. Those are 5 numbers. So this will stop at 87. You observe immediately that once you get the first 2 classes, a pattern emerges. And so for the next one, it is going to be 88 to what number? Well, between 82 and 87, there was a size of 5. So 87 plus 5, that will take me to 92. Then the next one starts from 93 minus 92 plus 5 is 97. The next one starts from 98, and 97 plus 5, that takes me to 102. So I have all the classes built out. The next thing is to find the respective frequencies. That is, how many numbers fall in each group. So how many numbers within the range 78 to 82 are in this data set? You have 8. For 83 to 87, you have 10. For 88 to 92, you have 6. 93 to 97, we have 9. And from 98 to 102, you have 3. So the total frequency is 36. And for relative frequency, you have 8 over 36. 10 over 36, 6 over 36, 9 over 36, and 3 over 36. You're welcome to convert these to fractions. You have 0.222. I'm going to do that. So we have all of the respective frequencies, or relative frequencies. We now follow up with the cumulative relative frequency. To get the first, that would be exactly equal to the first relative frequency. To get the second, it will be 8 over 36 plus 10 over 36, that is 18 over 36, followed next by 18 plus 6, that will be 24 over 36, 24 plus 9, that will be 33 over 36, and then 33 plus 3, 36 over 36, which is equal to 1. So this is done. And so on our screen, we can see the relative frequencies and the cumulative relative frequencies done. The next thing to do is question C. We've already completed how to establish the class width. And the next question is, how many classes are in the frequency table above? So number of classes, that is equal to 1, 2, 3, 4, 5. There are 5 of them. Then next, we're to determine the lower and upper class limits for the second class. For the second class, that class ranged from 83 to 87. So the upper class, the lower class limit is 83, and the upper class limit is 87. And next, we proceed to question D. Here, we are asked, what percent of the sampled crates have weights greater than 97%? As you might observe, 97% is right here. And so, we are only interested in weights greater than 97. So that would be the last one right there. And we're interested in the percentage. So this will be 3 out of 36. So 3 out of 36 multiplied by 100%, that will be 0.0833 times 100%, same as 8.33%.